Mhm.
Könntest du unten noch den Banner, den Toast unten ausblenden?
Ah, ja, sicher. Guter Hinweis, danke.
Okay, es kommen vielleicht nur 2, 3 Leute rein, aber wir sind bereits online. Sollten Fragen online kommen, dann werde ich die an dich weitergeben, okay?
Super, perfekt. Sollen wir starten?
Ja, leg los.
Okay.
Stage is yours.
Good morning and Mahlzeit. Thanks a lot for joining me. I'm glad that you're here. At first, before I start, a huge thanks to Rainer and his team for organizing Global Asia here in this amazing building. I think I've never did a lecture in a how's it name, a cinema lecture room. Can we say it like that? So a really cool experience. I think you have definitely better seats than I have. So I'm a little bit jealous, but okay, I have to do the clicking and the typing and showing you some things. So I would like to talk about how to deploy an OpenAI service with a GPT-4 model on Azure using Terraform and GitHub Action Workflows. So the double amount of automation. But before we dive into the topic, yeah, you know it. At first, a quick introduction. My name is Koch. I'm from Styria, from Graz. The Austrian attendees definitely should know the city. And lucky you, this lecture is now in English. It's good for you, I would guess. I work as a cloud adoption engineer at AVL. And I think AVL was already mentioned by Jürgen. Thanks for already promoting AVL, and thanks for joining my lecture too. Glad that you are also here. Feel free to get in touch with me using those channels. I will be also around for the full day. What is a cloud adoption engineer doing? Quite funny title. So in general, I'm dealing all the time with resource automation, specifically on Azure. So that I think Jürgen is also happy about. And who knows AVL? Okay, then it's worth to risk a slide for that. So AVL is a company which business is within the automotive industry. We are famous, or probably one of our most popular products, testbeds, combustion engine testbeds or testbeds for cars. But as you know, the automotive industry, yeah, it's a bit in a transformation. And so also we are. So despite from our traditional products, we also focus on, let's call it newer areas, so autonomous driving, electrification, data intelligence. To give you a better context, on the next slide, we'll see a short video about a combustion engine testbed. So what does it mean? You put your combustion engine on a testbed and you run several tests because you would like to know something about the emissions, about the speed, about the acceleration. And then in the end, we get some data. And lucky us, for operating such a testbed, we need software products. To store the data, we need software products. To do a visualization, we need software products. Therefore, as I would say, automotive company, lucky us, we also have to deal with software applications. But what do we have to do now with the cloud, as my lecture is about automating services on Azure? This happened in the year 2023, this global partnership. So for those who can't read it, so it's a snippet from a local newspaper from Styria, which says there's a partnership from Microsoft with AVL globally, and Microsoft would like to shape the future of mobility with cloud services and artificial intelligence until to autonomous driving. And that's why I have to deal a lot with the cloud, a lot with automating the services in the cloud. And this also brought me to get to this lecture, because I have to deal a lot with Terraform, a lot with GitHub Action Workflows and everything on Azure. And let's now dive deep into the topic. So we have Terraform, we have GitHub Action Workflows, we have Azure, respectively, especially the Azure OpenAI. Who of you folks already tried Terraform? Oh, then it's again worth it. So Terraform is definitely my favorite tool of automating resources on, in my case, it's specifically on Azure. You can also do it on AWS, on GCP, and on several other cloud platforms. So it's a universal tool. In general, you write so-called definition files in which you define, we will see it later on, so-called resource blocks. Imagine you would like to automate the creation of a virtual machine. What would you need, or what are the ingredients of a virtual machine? So on Azure, it would be a so-called resource group, which acts somehow as a container, so not in terms of a Docker container, but as a container to put some other services in to logically group it. And in addition, for a virtual machine, you need a virtual network, a subnet, maybe a public endpoint, a public IP address, and the virtual machine itself. And all those different items, you can you have a corresponding resource block in Terraform, which you can then define within a so-called definition file. But to get the full magic, so you have the code, but you have to somehow tell Terraform where it should get created. Should it be on Azure? Should it be on GCP? Should it be on AWS? Therefore, you need a so-called provider. You can think of it as a plugin which you download during executing Terraform commands, especially after the first Terraform command, which we will check later on. And then really think of a plugin which you download, which enables you to access the APIs of the cloud. So because you have to know somehow to create the resource group, to create the subnet, to create a virtual network, etc., whatever you would like to have. And here in my example, we will focus on an OpenAI service. So that about Terraform. So it's about infrastructure as a code. Just a quick slide for that. I think it's obvious for you what are the benefits of infrastructure as code. You define all the resources which you need in code, which means you can put it in a GitHub repository. You can, so you versionize it. You can trigger pipelines which grab the code and then simply deploy it. You have repeatable code. You are definitely faster. So think of, you have to, I don't know, deploy several Kubernetes cluster or a huge landing zones for different customers. You definitely won't do that using ClickOps within the Azure portal or some other portals. Definitely not a good idea. At least I wouldn't do that. Focusing on Azure regarding to infrastructure as code, we can distinguish here between imperative code. Example here for that you would see here. So that would be, for instance, done using the Azure CLI. What do we do here? In the first line, we would create a so-called source group named mydemo.rg within the location West Europe. And within this resource group, we put, which you can see in the next line, we will put a AKS, a Azure Kubernetes cluster. That would be an example for imperative code. The opposite, the declarative code, would be that. And there also, this belongs to more direction of Terraform. So constructing modules. So that would be already an example in Terraform of how to create a resource group and how to create an Azure Kubernetes cluster. It always starts here. So we have two resource blocks here. The first one is for the source group in which you put the AKS in. It always starts with the keyword resource. Then you have the type. In that case, in the very first line, it's a Azure RM, Azure Resource Manager resource group, which you provide some attributes, a name, and you have to go to a location. And Jürgen, as you announced, looking forward to use the Austrian data center in future. Then, for instance, for the Kubernetes cluster, again, we start with resource, but now we would like to have a Kubernetes cluster. So Azure RM, Kubernetes cluster. we define a name for it, we refer to a location already using the resource group, the same for the resource group name. Then we have a default pool, so the Linux VM, and yeah, you can provide some other thingy like identity and tags. This would already be almost a full example of how to easily create a Kubernetes cluster using Terraform on Azure. A little bit stuff is missing here. For instance, the definition of a so-called Terraform block, which is mandatory within a Terraform block. We'll come later to it. You define which provider you use. What does it mean, providers? You have to define somehow to which cloud platform I would like to have it at which cloud, at which subscription I would like to deploy my resources. Right, that about Terraform and infrastructure as code. And what we would like to do is to deploy an Azure OpenAI service on Azure. That was now 2 times Azure. So I think it's also quite obvious for you. So Azure OpenAI provides you to simply create an AI model on Azure, which you don't need to train. So there are already available deployments there, which you can configure, different versions, but just be aware, you always have to check for which region the different models fit. So there you have to simply check. And when you deploy such a deployment, 2 times deployment, to provision a deployment, much better. In the end, you get endpoints, right? Which you then can access either using REST API, or if you would like to try it within the UI, the fancy AI Foundry portal, you can also play with that there. And talking about large language models, general, it's an AI model program which simply generates for you text by guessing the new token based on the previous token. So you are, as provider of the prompting, somehow responsible to provide the input. And depending on the training data for the model, you get a cool output, or maybe a not that precise one, right? And that's also what's behind, for instance, the GitHub Copilot, which definitely many of you use, as we've seen before in the keynote. That what you can see here is a simple example of the GitHub Copilot, how it generates, how I get a suggestion in Terraform already for creating a resource group. As you can see, I simply type Azure RM, and already provides me resource group and some dedicated attributes. Coming now to the last item before we go to the live demonstration, which is probably more interesting for you as a guy talking about some basic concepts. Last thing, GitHub Action Workflows. So it's the automation process for GitHub. I used to work a lot with Azure DevOps before, so there it would be the corresponding thingy for instance, the Azure DevOps build pipeline, respectively the Azure DevOps release pipeline. We will go into more deep afterwards, but in general, as you can see here, for instance, we have here different jobs. So here are verification, and here I deploy. We will see it afterwards in action. And the idea now is to do following, to have a GitHub repository. Inside the GitHub repository, we have a so-called Terraform configuration, defining all the stuff which we need for the Azure OpenAI server, including the deployment. And we have a GitHub Action Workflow using YAML notation, and there we will deploy an Azure OpenAI service. And now let's go to the action. I switch here to my GitHub repository, which I named. So I'm not very good at naming. I named it Terraform Azure Cognitive Deployments. If you would like to play with that. So what's included here, let's check that within Visual Studio Code. Hope you can read that. So the main contents are at one point the Terraform configuration. So those are those guys here, the main TF, the Terraform TF, the Evangelist TF. What do we do here? That stuff, what you can see here, that's sufficient for deploying an Azure OpenAI service with a GPT-4 deployment. So I will fill it up afterwards with data. But in general, what do we have again? We have a resource group. We have a so-called cognitive account. That's a thingy, so you can really think of an account which you have to create before to access several or other services from Azure OpenAI, right? And using this cognitive account, I can deploy a cognitive deployment. So this cognitive deployment needs this cognitive account as a prerequisite. And this cognitive deployment, that's now the probably most interesting one. That's where you can say, I would like to have a GPT-4 from the version Turbo, or I don't know, some specific one which fits for your region where you would like to have it in. In addition, so the Terraform configuration contains 1, 2, 3 different files, always ending with .tf. What's definitely mandatory is this Terraform block, right? So here you have to define a provider as we would like to deploy it on Azure. Our provider is the Azure RM Resource Manager. Azure Resource Manager, Azure RM. You can define a specific version. So there will be newer versions for the provider, so extending the APIs, redefining the APIs. So definitely be aware how to use the versioning here. Greater equals maybe not the best one, but it fits definitely for this small demonstration. And in addition, you also have to set this provider here. So we stick to Azure. To complete that, we have, oh, I need to clean up. You also have some stuff like that. Let's switch here where you don't have comments. So what do we here within the variables TF? As the name says, you define variables using always the keyword variable. And here, for instance, we define a variable for the resource group. Here for the group location. Here for the name for the cognitive account, etc., etc. Until to the end, to get some better imagination. Here, for instance, you define that you would like to have an OpenAI thingy. Here you define that it's a GPT-4. Here you define that it's a Turbo from a specific month, which was published by Microsoft, and so on. We will see it later in the workflow. So that's part of the GitHub repository. And in addition, we have defined a so-called workflow, which you define in a YAML. So in general, what do we have here? I define here several jobs. At first, my first job is called verification. There I simply verify that all the parameters which I need for the deployment are definitely set for the Terraform configuration. If that fits, I have a deploy. So we provision here the stuff, which is dependent from the previous one, so which needs the verification step. We run it on an Ubuntu GitHub runner, which is hosted by GitHub, so it's not my personal runner. So thanks for that, GitHub. Then what we do here, we check out the repository, so the GitHub, the Terraform configuration, sorry. We set up Terraform, right? So we need a few commands to execute. So we have to let the GitHub runner know that it's now about Terraform. We set a few variables. So we do here, among other things, some stuff for the authentication, because we need to let Terraform know to which Azure subscription the deployment has to be done. And then we fill up all the parameters which we have in GitHub secrets, respectively GitHub variables, because we would like to parameterize the deployment. So that we need to parameterize the Terraform configuration for running it afterwards. Afterwards, we do a Terraform initialization. So at the directory at which we have the checked out Terraform configuration, we have to initialize it, to download this plugin from the provider to be capable to run the further Terraform commands, which are validate, name says it all. It checks, among other things, the syntax of the Terraform configuration. We create a execution plan first. So this provides you in the logs a full overview of what you are going to do. In that case, deploying 3 different resources: the resource group, the cognitive account, and the cognitive deployment. And afterwards, the action happens here. And now let's see it live. So I'm back here at my GitHub repository to prove it. That's now the Azure portal. And as you can see, no Azure OpenAI is getting displayed here, so nothing is provisioned so far. I switch here to actions. I switch here to my only one workflow named OpenAI Service. And here on the right side, I simply click here on Run Workflow. Based on the main branch, I would like to deploy a specific environment. Within this environment, I simply also provide some further variables, which I would need here. And let's see what happens. So we release now a job. We first check, or we first go here to the verification. There, as the name says, there are some checks that all the parameters which are needed are definitely set. And now we are at the deploy job. So here we check out the repository on the GitHub runner. We do the initialization of the working directory for Terraform. We do Terraform validate. We do the Terraform plan. And as you can hopefully see or read, what we would like to have is a cognitive account, among other things, and the cognitive deployment and the resource group. So in general, from the view of Terraform, there are just 3 services to deploy. And that's what's going to happen here. As you can see here in the log, hopefully, maybe I can zoom in, but I will tell you. So the first thing which is going to getting created is the resource group, because within the resource group, we will have all the other services, so the cognitive account and the cognitive deployment. Here in the logs, we can see that the cognitive account is also completed, and that was fast. So let's switch to the Azure portal. Let's do a refresh here. And as you can see, we have here now the cognitive account, right? So let's click on the cognitive account, which includes the deployment. So I switch now here to the Azure AI Foundry portal. So that's the comprehensive platform for doing all the AI stuff. You can tell you definitely better as I can do. And we have deployed our GPT-4. And here we can already chat. Hello, what is global Azure Austria? And you definitely know the prompting. That's definitely nothing new for you. So just to prove to you, we can already play around with it in the Foundry, but in addition, and if you would like to do some more development, if you switch here to deployments, we can now see in a better way what is getting deployed here, or what was deployed. It's already done. So we have a GPT-4 from a specific version, which is in that case Turbo 2024 or 0409. Succeeded, of course. And then the next time I have to replace it. And let's go inside the deployment here. And here we have the endpoints, currently public. For demo purposes, it's fine. If you would like to do something in your company with it, maybe use private ones. But to give you a quick demonstration, what you can do with that, I copy now, for instance, the target URI. I switch back to my repository within Visual Studio Code. I have here a little Python script, and I'm going to replace now this old endpoint. Of course, I've tried it before to just to be sure. So all what you can see, it's live. So yeah, sometimes you have to live on the edge. I also get now the key. Place it here. And what do we going to do here is we define here a payload where we set here for the system content your helpful assistant, of course. What should be the other way? And again, the question, what is global Azure Austria? So let's save that. Then we have to switch into the directory scripts, right? And then let's execute that. Send requests, and we should see some familiar, similar response. Yeah, here. So what is global Azure Austria? And we say as a response, global Azure Austria is part of a larger global Azure initiative. So yeah, I think you get the point. And those are now the two ways how to immediately start using your quite quickly deployed AI deployment, which is a GPT-4 in that case, right? And that's done using Terraform and GitHub Action Workflows. How to get now all the inputs here? Let's switch back here to GitHub. So I go here to settings. So how does he know how to parameterize it? So here I add secrets and variables. I check here actions. And here, as you can see, there are some bunch of repository secrets. So using that, Terraform knows where to deploy it. So, and how to authenticate and being able to authenticate, because we have to let Terraform somehow know, okay, at first I'm able to authenticate. If you do it in manual way, you can use, for instance, the Azure CLI for that. Within the GitHub Action Workflow, it works in a different way by also using a so-called service principle. And in addition to that, to doing the parameterization of your GitHub, of your AI service, you have a lot, or I have a lot of variables here. Maybe you can also summarize it within a GitHub environment. But as you can see, what do I have here? I would like to stick to OpenAI. I have a specific SKU name. I would like to have a GPT-4 from a specific type, global standard within West Europe, and I simply provide names for my resource group, for the cognitive deployment, and for my cognitive account. And if I don't want to have that anymore, of course, to get also use the remaining job here, I go here to workflow. Now I switch here to destroy and trigger it. What's happening here? If I can switch to the YAML for the workflow, so the destroy, as the name says, we again have to do some kind of authentication. And in the end, we simply type Terraform destroy. So as a conclusion for doing a provisioning using Terraform, for this example, I used the Terraform init. So to set up the working directory in which you have your Terraform configuration to let Terraform know, here at this directory, there I will download the plugin, which then allows me access to APIs, in that case for Azure. I will do a Terraform validate, check is the Terraform configuration all right. I will do a Terraform plan to get the execution plan. What's going to happen? Deploying, provisioning, in that case, 3 different resources. In the end, Terraform apply, so getting this plan in action. And respectively, if you would like get rid of it, I run Terraform destroy. And you can easily integrate it within a GitHub Action Workflow using YAML notation here. So let's see what happened here. The job is now released. We're already at the destroy part. And here, not the opposite from the one before, we now would like to destroy a lot of things. Yeah, 3 items. So the cognitive account, the cognitive deployment, and the resource group. And when we are done, so it's still destroying here, takes a few minutes, but afterwards we should see that, oh, already happened. So, and it's already gone. We save costs. That's fine. So also be aware, of course, sometimes it's a little bit more expensive if you forget to destroy something. Don't do that. No, you definitely know that. And switching back to the slides. Okay, maybe it's not that thrilling, the conclusion. So what I wanted to show you is how does Terraform work combined with GitHub Action Workflows for deploying, as everyone is talking about AI, in that case, how to deploy an Azure OpenAI service with a specific deployment. In that case, it was a GPT-4. As you can see, it's created within a few, was it a minute? I don't know, but quite fast. And you're immediately able to access the endpoints, use it within your, I don't know, your C# code or your Python, whatever you would like to do, or you can use it already within the AI Foundry, so this platform. So I hope, according to the time, I think, okay, definitely a lot of time left for questions. So thank you very much that you've been here for joining me. I hope this was a meaningful lecture / demonstration for you. Looking forward to questions, but we can also talk, of course, at lunch or for having a coffee, as you prefer. Will be here. And yeah, thank you so much for the attention. Thanks for being here, and enjoy Global Azure Austria, the next lectures. And thanks, Rainer.
Thank you so much. Do we have questions? Yeah.
Thank you, first of all. The format of that Terraform looks very similar to Bicep. So I'm wondering whether I can use Bicep as an alternative connect, or is there any advantage if it is another tool? Just some clarification.
Yeah, good question. Looks similar, right? Yeah, but the main difference here would be that Bicep, but Rainer is definitely more expert in that as I am, you can only use it for Azure, right? So Bicep would be the infrastructure as code language, Azure native, right? Can we say it like that, Rainer? But Terraform, you can try it also for several other cloud platforms. So there are thousands of different providers which you can use for Terraform. So starting from Azure to Google to AWS, whatever your business case is about, whether you would like to develop. But it's maybe important to mention. So for instance, that's what you can see here also. So these resource blocks, in general, you also have, for instance, for AWS resource blocks, but they are definitely different. So for instance, that here, the Azure RM cognitive account, that's Azure specific. For instance, in comparison to AWS, what's quite a famous service there, the S3 bucket, for instance, in AWS, that wouldn't fit, of course, for Azure. Therefore, a resource block for the S3 bucket won't exist for Azure, but for AWS. So you have to you have to stick to all the stuff which your provider is providing you, right? So you have to rely on the APIs, which Azure, which Google, which some other cloud providers provide you. Hope, does that answer your question? Okay, great.
Can I elaborate for a second? If
Yes,
anybody's
please, Werner.
looking for an example with Bicep, I have a working example that does something similar to what Patrick just presented. So if you would like to have a template in Bicep, just send me a DM or tell me, come to me, and I can provide you with the Bicep sample too, and then you can make up your mind. That's one thing. And the second thing is, correct me if I'm wrong, one big difference between Terraform and Bicep is the state management. Terraform is really storing state, while Bicep doesn't have any state. So it
Okay,
life compares the
I have too less knowledge, to be honest, about Bicep, but it's definitely true for Terraform. So
and it's definitely true for Bicep what I said. So
okay, then it fits. Yeah. So for Terraform, when you apply all the commands, you create a so-called Terraform state file, and yeah, that's the difference here.
Yeah, and Bicep doesn't have it. Next question.
What's the benefit there for the state storing?
You mean for the state file?
Yeah, what's the benefit of the state storing?
In comparison to Bicep or in general?
I guess general.
I think what is the advantage?
Yeah.
Let me ask you a question. Maybe this, what I always have in mind is, correct me if I'm wrong, in Terraform, if you remove something from the Terraform script, Terraform will recognize that I removed it and can somehow also remove resources. Is that correct?
Definitely true. That's what I said. So what we've seen before, we provision free resources. So the state file knows about free resources, right? If you remove now, as Rainer said, one of the resource, it's getting compared with the state file, right? And then it recognizes, oh, okay, one resource is removed. Okay, let's remove it from Azure in that case. So in a nutshell, hope the explanation was well.
Yeah, and for Bicep, this is not the case. If you remove something from a Bicep script, the Bicep script says, I don't care about things that already exist, because maybe the user has created this stuff on his own and he wants to keep them. If you want to have the same behavior in Bicep, as you have just heard from Patrick, you have to use so-called deployment stacks. When I do trainings for Azure, I often recognize that people are not so familiar with Azure deployment stacks. They are an amazing tool, and deployment stacks add state to Bicep. So take a look at Bicep together with deployment stacks, and you get something similar Azure native as in Terraform. Yep.
So why one should use Bicep at all? I mean, is there any disadvantage of Terraform at all? So as a developer, I want to
It's simply the question, would you like to go for Azure only or not? If you have a multi-cloud approach, maybe don't use Bicep in that case. So use Terraform. But yeah, it really depends. If you, within your company, if you would like to go for several cloud platforms, just using Bicep probably wouldn't be the best idea, I guess.
Yeah.
Just generally speaking, is there any disadvantage of using the Terraform?
Yes.
So you mean you would like to stick, for instance, to Azure only, and but in all four, you just would like to use Terraform only in contrast to Bicep. Is that what you mean?
I mean, if it is Azure only, also I can use the Terraform. Why I should use Bicep at all? That's yeah.
Can I give my 2 cents here?
Yes, please, because compared to in contrast to Bicep, my knowledge is too low, unfortunately. But Rainer will help out things.
That's lucky that we are both on the stage here.
Yeah, that's a good thing.
You have an additional tool. You need to manage the infrastructure. You need to learn an additional tool. You have an additional vendor. You have to check for additional dependencies. You have to update something. You have to maybe pay for something additional. So Bicep is simply built in. So if you say, I'm Azure only, and I want to use tools that are perfectly built in, perfectly integrated into the portal and so on, Bicep is amazing. But as Patrick said, if you are working in a company and you have to deal with Azure today, AWS tomorrow, and maybe some Ansible scripts or your Kubernetes cluster the day after, then maybe you want to have a single tool with which you can manage all of them. Still, you have to learn about Azure, what Patrick told you, but you have at least the same tools.
And in addition, it's not just about cloud platforms per se. For instance, with Terraform, you also can automate your GitHub resources. You can write Terraform configs for automatically creating repositories and all this stuff. Why you should do that? Think of certain policies which you definitely would like to enforce. Yeah, that not all developers, especially in a huge company, which I am, are allowed to create now GitHub repositories, which are, maybe then public, maybe not a good idea, don't fit to specific policies, etc. You can also use automation there, for instance.
Do we have an additional question? Then let me close with one question to you. Is Terraform open source, or might it happen that I have to pay for Terraform?
So that thing what I've shown here to you, that's open source. So there's a specific, let's call it Terraform native. I think in terms of HashiCorp, it's called Terraform Community Edition. But as definitely raised, be aware that for specific use cases, it depends what you're doing with Terraform, you maybe need to pay something, right? That it really depends on what you're going to do. If you are going to be some kind of competitor of HashiCorp, then it's a high probability, high likelihood that you have to pay something. If you use it like that, as I've shown to you, then I hope I'm not wrong, but then it should be free. And in addition, there also exists a cloud derivative of Terraform, so it's more managed. There you guess you have to pay.
Amazing. Any additional questions? If not, we are perfectly in time. Thank you very much, Patrick. Thank you.
Thanks for having me, and thank you so much that you joined me. It was a pleasure, and see you.
Very good. We have give Patrick a round of applause.
Thank you so much.
We traveled all the way from Graz to Linz yesterday already, so thank you for your powering.
It's such a long journey.
Helping Global Azure.
Thanks for
Now we have a break of exactly 10 minutes, and then again you have to decide between AI, which will continue in this room, and I think you have to mute your.
Just plug in that.
Okay, 10 minutes. Here AI and DevOps in the other room. So decide.
Sorry for that.
Enjoy the break.
Entschuldigung für die Soundgeräusche.
Kein Problem.